In this video, we're going to take a look at using a hex display. That is an output device, and there's two versions of it. The 7-segment display lets you control each individual segment here and turn it on and off individually. That's not what we want. What we want is the hex display. And if we input a 4-bit number here, this will display a number from 0 through F. And this input right here is for the decimal point or the hex point or whatever you want to call it. It's for the little dot that goes there. That is off by default. If you want it to be on, you input a 1. We're not going to worry about that. Okay, so what we need here is, this is a 4-bit input. And let's go and create an input for it. And again, we'll do this the wrong way first and show you what happens. I get incompatible widths because it's expecting 4 bits and I'm only giving it 1. So let's go over here and change our data bits to 4. And now we're good. Now let's go up here and start running the circuit. If these are all zeros, it shows me the number 0. If these are 0, 0, 1, it shows me a 1. If I show it a 2, it gives me a 2. If I input a 3, it gives me a 3. If I input a 4 and a 5, and we'll turn that off and do a 6 and a 7, and trust me, the rest of them work all the way up to F. Okay, so that's one possibility. Now, if your input, which is very possible, is coming from 4 separate lines, let's put 4 separate lines out here. Okay. And I want to take these 4 lines and put them all together and run them into here. So I need something that will take 4 lines and basically combine them into a single line on my display. It's still 4 data lines, but it's going to look like one line, just like this one does down here. Okay. So it'll be a 4-bit data bus, but it will look like a single line in the diagram. So what I need for that is I need something called a splitter. And a splitter will take multiple inputs and convert them into a single output. So here's my splitter. First of all, I want to turn it around so it's facing these numbers over here. So we're going to make it face west. And it's got 0 at the top now, which is what I want. I also want 4 bits coming in. So we're going to change the bit width in to 4. And the fan out also needs to be 4 as well. So it looks like it's expecting 2 on here and 2 on here, and they'll combine them into 4, but I want 4 bits. Okay, so this is the low order bit, the 1s column, and the 2s, the 4s, and the 8s column. And now what I'm going to do is I'm just going to take these lines and I'm going to run them into my splitter here. Actually, it's not really splitting, it's kind of going back in the other direction and unsplitting. Okay, and this is the output. There's not really a blue dot or anything here like there frequently is, but that is the output. And we're going to take this output and we are going to run this into the data bits on our hex display. And now we're going to start the circuit up. And I'm going to change this to a 1, and we get a 1 for an output. I'm going to turn that off and now do a 2, and we get a 2 for an output, 3. 3, 1 should be a 7. 4, 1 should be an F. Turn that off, and I should get that should be a D, I think. I'm sorry, it's a B. That's what a hex B looks like. Otherwise, it would look like an 8. This should be a hex A, and hex 8, and so on. So you can go through all possible combinations of 4 bits here, get a hex number from 0 through F, and it will be displayed appropriately over here. So if you've got individual bits, you can combine them using a splitter and run that in to the hex display. If you've got all 4 bits together, like in this case down here, then you can just run that directly into the display. So that's how a hex display works.